Limiting reactants. When reactant quantities are not in exact mole ratios, such as in the example below, we can see here we've got 2 green atoms react with 1 red atom to form a molecule that looks like this. We have an excess reagent. We have 1 excess red atom that hasn't reacted. This is not all used in the reaction. We also have a limiting reactant. This is the reactant that's used up in the reaction, and it limits the amount of product that's formed. And you can see here, because there's only 4 green atoms, only 2 molecules can form. So this limits the reaction and limits the amount of product. Let's use pancakes. We've all cooked pancakes before. We know that 1 egg plus 1 cup of milk plus 1 cup of flour will make about 12 pancakes. Let's think of this as a chemical reaction. If we've got 4 eggs in the cupboard, we can still only make 12 pancakes, and this is because we've only got 1 cup of milk and 1 cup of flour. So these ingredients here, or reactants, are called the limiting reactants because this is limiting how much product we can make. Doesn't matter that I've got 4 eggs because I'll only use 1 egg and I'll have 3 eggs in excess. And these are called then the excess reactant because I have more eggs than I actually need in the reaction. Another example here, when making sandwiches, I need 2 slices of bread, and each sandwich then has 3 pieces of meat and 1 slice of cheese. If I've got 6 slices of bread, 12 pieces of lunch meat and 5 pieces of cheese, I can make 3 sandwiches, but I'm going to have this left over. The bread then is said to be the limiting reactant because I've only got 6 slices of bread, I can only make 3 sandwiches. Doesn't matter how much meat and cheese I have. So let's look at a chemical reaction. Magnesium plus oxygen makes magnesium oxide. So 1 magnesium reacts in a mole ratio with 2 oxygen molecules. If I have 10 magnesium and 2 oxygen, I can still only have 1 magnesium reacting. So magnesium is in excess. It is the excess reactant. 9 mole of magnesium does not react. Only 1 can react with 2, and I've only got 2 of the oxygen. So the oxygen is the limiting reactant. And it is this mole ratio here of the limiting reactant that we must use in our calculations to work out the amount of product. Another example, if I've got 1 of magnesium and 5 of oxygen, again I need to have a look. It can only react in a 1:2 ratio. So here oxygen is in excess. 3 mole of oxygen does not react. So magnesium is the limiting reactant, and again we use the limiting reactant in calculations because this is the amount that will react with this to form our product. So let's look at an example question. In the Haber process for the production of ammonia, nitrogen and hydrogen are reacted according to the following equation. If 2 kilograms of nitrogen is reacted with 1 kilogram of hydrogen, which reactant is in excess and by how much in terms of mass? And the second part of the question is what mass of ammonia is produced? Okay. So the first thing we want to do is look at the important parts of the question. So we can see here that 2 kilograms of nitrogen, here's our nitrogen, will react with 1 kilogram of hydrogen, here's our hydrogen. It reacts in a 1:3 ratio. We're trying to find out what's in excess and by how much in mass, and then there's a second part of the question to work out the mass of ammonia. So let's put all of that information here that we know. So we know that mass equals 2 kilos, which equals 2,000 grams, and we know the molar mass from the periodic table is 28 grams per mole. For hydrogen, we know that the mass is 1 kilogram. We have to change that to grams, so it's 1,000 grams, and the molar mass is 2.0 grams per mole. We want to find out the mass of ammonia, and we know its molar mass there is 17.0 grams per mole. Always write down all your information. So the next step and the easiest way to do up is to set up a table like this. Here's our equation, and here's one reactant and the other reactant, hydrogen. So the information that we know. The next thing to look at then is the mole ratio. It reacts in a 1:3 ratio. So 1 mole of nitrogen will react with 3 mole of hydrogen. We need to look at the number of moles available, and we can do that by using N equals M on M. So here we have 71 moles of nitrogen available, and based on M on M here, we have 500 moles of hydrogen. This is how much is available. We now have to look at how much can actually react. So the moles required. If I have 71 moles of nitrogen, it reacts in a 1:3 ratio. So I'm going to need unknown over known times 71. I'll need 213 mole of hydrogen to react with 71 mole of nitrogen. It's a 1:3 ratio, so this is 3 times as much hydrogen is required as nitrogen. Do I have this much hydrogen? I've got 500 altogether, so yes, I do have that much hydrogen. So that's okay, that will work in this direction. Let's look at the other way. If I use 500 mole of hydrogen, 500 mole of hydrogen, it's a 3:1 ratio, so I'll need a third of this amount, unknown over known times 500. I'll need 166.7 mole of nitrogen. I don't have that much available. I've only got 71 mole of nitrogen available. So this reaction can't go ahead. So nitrogen is our limiting reactant, the 71 mole here, and we can see here that hydrogen is in excess. 213 mole is going to react with our 71 mole of nitrogen, and that will leave some left over, which will be 500 minus 213, which equals 287 mole in excess. So we know that there's 287 mole of hydrogen in excess, so we can now work out the mass remaining, which equals N times M, which equals 287 mole times its molecular mass, which will equal 600 grams or 0.6 kilograms of hydrogen remaining. The second part of the question wanted to know what mass of ammonia is produced. So we've just worked out that the number of mole of our limiting reactant is 71 mole. It's a 1:2 ratio here of ammonia produced. So number of mole of ammonia equals unknown divided by known times the number of mole, which equals 2 divided by 1 times 71. So we have 142 mole of ammonia produced. So now that we've calculated the number of mole of ammonia, which is 142 mole, we can work out the mass, which is the number of mole times molar mass, which is 142 times 17, which equals 2,400 grams. At this point, double check that's what you're looking for, the mass, that is, so that's the answer to the question. So here's a question for you to have a go at. Have a read through, pause the video, have a go at it, see if you get the right answer. Okay, so the limiting reactant is oxygen, and magnesium is in excess by 0.125 mole. The mass of magnesium oxide produced is 5.04 grams. If you've gotten that right, don't worry about watching the rest of this video, but otherwise I'm going to go through step by step how I got that answer. So first thing to have a look at is the question, and look at what information the question's given you. So I've got magnesium, I've got 6 grams, and I've got 2 grams of oxygen reacting. I need to know the limiting reactant, I need to work out the reactant in excess, and I'm also trying to find the mass of magnesium oxide. So let's put all the information that we know into or underneath the equation. So my mass is 6 grams. My molar mass is 24.3 grams of magnesium. Of oxygen, my mass is 2 grams and my molar mass is 32.0 grams per mole. And I'm trying to find the mass of magnesium oxide, and I've got a molar mass of 40.3 grams per mole. So we'll use a table again to work out what the limiting reactant is and what the reactant in excess is. So our information we know. Our mole ratio we know from the equation, so it's a 2 to 1 mole ratio. So 2 moles of magnesium reacts with 1 mole of oxygen. Let's look at the moles available. So using our information up the top, we can work out the number of mole equals mass over molar mass, which equals 2.250 mole of magnesium, and the same with the oxygen, 2 divided by 32, which will give us 0.0625 mole. This is what's available, it's not what's going to get used. The moles required, if I have 0.250 mole of magnesium, I'm going to need, on a 1 to 2 ratio, unknown over known, times 0.250, I'm going to need 0.125 mole of oxygen. Do I have this much oxygen available? I have a look up here. No, I don't have that much available, so this is not our option. Let's look the other way. If I have 0.0625 moles of oxygen, how much magnesium will that need to react with? Well, it will need to react with double the amount because it's a 1 to 2 ratio. So, unknown over known, so it's 2 times 0.0625, which equals 0.125 mole. Do I have this much available? Yes, I do. So, this reaction can go ahead. That means that the magnesium is in excess, and it's in excess by 0.250 minus what's reacting with the oxygen. So 0.250 minus 0.125, so it's in excess by 0.125 mole. This is our limiting reactant. So this is the amount of mole of oxygen here that we use in reactions from here on. So here's our information. We've just worked out that this is the limiting reactant, so this is the number of mole that we're going to use to work out how much magnesium oxide there is. So the amount of magnesium oxide equals unknown over known times the amount of oxygen, which equals 2 over 1 because it's a 2 to 1 ratio, unknown over known, times the number of mole, which equals 0.125 mole. So we use that 0.125 mole and we can work out the mass, which is number of moles times molar mass, which is equal to 5.04 grams.